Hi, this is our part 5 and our final part of 3.5 transformations. This is a problem I wanted to create. You notice there's some similarities with my previous parts. On the horizontal shifting, when you go left to right, there was an x plus 4 squared I gave you. And there was another that was a plus 3 or a minus 3. That was a vertical up or down. I chose the minus 3 on the one I wanted to show you. Remember on the stretching, I gave you a 2 on the front of it. So this is actually little bits and pieces of every one of the previous parts. And remember there was a negative in front of one of those was the vertical reflections. Now what am I not showing you here is a horizontal reflection. I am not showing you a vertical shift up. I am not showing you a horizontal shift to the right. But there are multiple transformations that are being applied here. This is a horizontal shift. This is a stretch. This is a reflection. And this one here is a vertical shift down. There's actually 4 different types of transformations. So now, every time you have a transformation, I call the transform function, a child graph, because I call these parents. That's why I call them parents. So if these are parent graphs, every time you transform a graph, that is a child graph. So in other words, the child looks kind of like the mom and dad. Maybe it's moved to another location, or is that there, or it's been distorted, but it's still part of the parent. So that's why I call them a child. Well, this child is got 4 different characteristics. So this child actually has a multi-personality child. So has 4 different personalities. It's not. I don't guess that could be a good thing, but anyway, this is a graph that has been shifted 4 units to the left, stretched by a factor of 2. You vertical reflected the function. In other words, you turn it upside down, and then you shift f of x 3 units down. So this was the part 1. This one right here was part 3. I believe part 4. This one here was part 3. That's actually part 2, actually. So, and this one was part 2 as well. So, but anyway, now you're like, well, how do you know which order to go? It's kind of like working yourself outside of a parentheses, like order of operations. You do horizontal shifts first because they're inside the parentheses, and then you do the 2 next because it's the next thing outside the parentheses, and then you do the negative. So it's kind of like the order of operations. So that's how I can remember it. And then the minus 3 is the last thing you do. Now, is that a guarantee you're going to get it wrong if you don't? Not necessarily. I mean, sometimes it'll turn out you're okay. You can do these in any order, and you may not be a problem. But there are some instances that if you do them in the wrong order, your graph becomes more distorted, and then it's not the right kind of distortion. So if you stick, with the inside of the parentheses on your way out of the parentheses, and do the vertical shifts up or down last, you'll be okay every time. So, but anyway, so what I'm going to do is I'm going to take the function and I'm going to move it 4 units to the left. So you take this graph and you go 4 units to the left. You go 1, 2, 3, 4, and it looks right there. And so if you do this graph right here, this is the vertical shift, the horizontal shift to the left, 4 units. That's what it looks like. Now the next thing, you're going to stretch it by a factor of 2. So now it looks skinny because of the 2. The 2 makes it look skinny. So then I don't want to get too much on there. So now instead of 1 unit apart, now it's going to be 2 units apart. Now it looks thinner, but you got to go through the point. You don't miss it like I just did. So now it's 2 units. Now this one was just slightly skinnier because the units are not that much. I mean, if I made this a 5 instead of a 2, then you would see this one's going to go from 1 to 5, and then it looks really thin if you do that. So that's the stretch. So then the vertical reflection is getting this graph and just turning it upside down. So I'm going to keep this one here just for a little bit, and then use that to just show me what it would look like. So I'm going to erase this. So what do you think? So yeah, you went left, then you stretched it, and then you turned it upside down. Okay, and then there's one thing to do. That minus 3. So you do it point by point. You take all your graph and you make a snapshot of it, and you move it 3 units downward. So this point right here, we'll go 3 units down, this one right here at -2 will go down here to -5. And this one here, -2, will go down here to -5 as well. So that's what the graph looks like. So this is the child with the multi-personality. That's what this one's going to look like. So it's a distorted. There is a distortion here because it is a stretch involved. So you went 4 units to the left, 3 units down, and ultimately that's where this point can. And a lot of people use that point as what we call a hinge point. And what I mean by hinge point is they'll take that point and find a location for it, go 4 units to the left and 3 units down, locate the hinge point, and then do it and then work everything else around that. And that's fine. That's fine. You can do it that way as well. And so 4 to the left, 3 units down. So take the hinge point, go 4 to the left and 3 units down, plot that point, and then work around that point there. So that's a way you can work around it. It's doable that way. So and again, you know, if you don't have the negative in front of the 2, then that's no big deal. All this graph is going to do then is just going to look like this. It's just going to stay right side up. So the negative in front of the number is just going to turn it upside down. That's what the negative does. If you want this same shape, but you want it up here in the second quadrant, what would you think? Instead of subtracting 3, you'd add 3. So you would take, if you have a +3, you'd go 4 units up, 3 units down. It would have the same exact shape. That was +3. If you want to go to the right, then you have an x minus 4 squared, so you'll go 4 to the right. And depending on which number you want to make that, go up or down with it. So these are the types of transformations. And again, most of your graphs will have multiple transformations. You're not going to be, you luck out with just one type of transformation. I mean, if you have like 2x squared and that's a stretch a factor of 2, and that's all you have, then count yourself lucky. But most of the time, you're going to have multiple transformations, at least 2. I'm giving you 4. You're probably going to have a minimal of 3 on some of these problems, maybe 2 at the least. 3 is normal. 4 is pretty much normal as well. Can you have 5 or 6 transformations? Yeah, you can. You would, if you slap a negative in front of the x right here and a negative on the outside, you would also have a horizontal reflection. And I'm not going to do that one on this particular problem. So, but this is about as bad as you probably would see something like that. Now, I want you to understand, I'm doing the parent graph of x squared. Now, if the parent graph was f of x equals x cubed, there's no big deal. I mean, it would be the same shape. It would be just a different shape. So the parent will be different. If this was x cubed, it looks like that. Then the child with the multi-personality will be just upside down from the parent. So that's why I showed you x squared, because that's standard. I mean, you could do it x squared, x cubed, x to the 4th, x to the 5th. It really doesn't matter. So if you have the square root of x, well, the square root of x from your previous section you've learned looks like this. And then that's what the square root of x would look like that. And then based on that parent graph, you can turn that parent graph upside down if you have a negative in front. If you want to stretch that square root graph, then you'd have to put a 2 or 3 in the front. If you want to move it to the right, then you'd have to have the square root of x minus 5, and that'll move it 5 units to the right. So it just kind of depends on the parent graph. But the parent graph is what they call a basic shape in the book, in your MyMathLab. They'll call it the basic shape or the basic graph. I call it the parent graph. Because I want to have a parent-child relationship there with my graphs. And to me, it makes more sense. And that's the way I was taught many, many years ago. So, but anyway, this is 3.5. This is part 5 of transformation. This is it. And like I said in the initial part 1, there is another problem that deals with an x cubed graph. So if you want to see another example with a multiple transformations, is also in the YouTube videos as well. Probably if you just find something that says transformations in it, that does not have part 1, 2, 3, 4, 5 on it, then that's the one I'm referring to. So, but anyway, again, please keep asking for questions. It fills my library, and this makes everybody's life a whole lot easier. So thanks a lot for listening and watching.